So let's keep practicing finding some double integrals. Now in this particular one, when we look at it, we can see that it's y over x plus y dy dx. However, when I'm looking at that, I'm thinking y is in two positions. So that means integrating with respect to y is actually going to be tougher. X is only in one spot, down in the denominator. So it'd be a lot easier to integrate with respect to x first than with respect to y. So we're going to reverse the order. So I'm going to make a note. There are two y's in the function, so reverse the order. It's not the only consideration, but that's a good one to look at, because you've got to think ahead and think about integrating this thing. Okay, so my first mission is going to be to reversing the order. So I'm going to go from 1 to 4, then from 1 to 2, y over x plus y, dx dy. All right, well, now if I want to integrate with respect to x, x is only in that denominator. So let's do a little u sub again. If u was x plus y, then the derivative of u, technically it's a partial derivative, of u with respect to x would be 1 dx. Okay. So let's rewrite this integral. This is the integral from 1 to 4, and then another integral. I'm not going to put values in there because it's no longer x. So y over u du, and then dy. I'm just doing this so you can see how easy the integral is going to be, because the integral of 1 over u, or y over u, y is just a constant, is the natural log. So this is really the integral from 1 to 4 of y times the natural log of the absolute value. Let me do it this way. Y times the natural log of the absolute value of u dy. Right? So I've integrated. I didn't have values, so this is not perfect because I would need, u values. I would need to go from u equals something to u equals something, which I didn't bother to figure out. So u equals to u equals, but that's okay because I'm about to put back an x. So this is the integral from 1 to 4 of y natural log of x plus y. And this originally went from x equals 1 to x equals 2 dy. Okay, so that's the integral from 1 to 4 of y times the natural log of 2 plus y, take away y times the natural log of 1 plus y dy. Right? Because I'm putting 2 in for x, I'm putting 1 in for x. Okay, I mean, I'm just going to make Maple do this, right? So that's the trick when we get to these. So if it gets too hard, we're just going to make Maple find it, right? That's the beautiful thing. Okay, so let's go to Maple. And then this was example 4. So I told it to integrate this original function from from y equals 1 to 4 to x equals 1 to 2. And it gave me this answer, which is the exact answer. Here, it's probably too small for you to see. Let me make it bigger. There you go. So it's this exact answer, which is really annoying. I'm not even going to write that. So then I said, hey, yep, do that again, but make it numeric, please, and thank you. And so then it gave me a decimal approximation. So if you want to see what we're doing, we have this surface, which is y over x plus y. That's that rainbow surface here. And then we have the rectangle down below in the xy plane. And so what we're doing is we're finding the volume of the space between the xy plane and that surface, which in this case is 1.828 roughly, whatever, meters cubed, centimeters cubed, inches cubed, we don't know, right? But that's what it would be. All right, let's do it again. So we're going to find the volume of the solid beneath the paraboloid, right here, 12 minus x squared minus y squared, but above the region here, right? So we're going from 1 to 2 for our x and 0 to 1 for our y. So just this little section of it. You can see it's very small. All right, so volume equals the integral, with the double integral actually. All right, so we're going to make x go from 1 to 2 and y go from 0 to 1. The order on this one doesn't make any difference. 12 minus x squared minus y squared, and then dy dx. And I just realized there's a typo here because that says 12 minus x squared minus 2y squared. So this should say 2y squared right here, just to match the picture that we have. It's such a nice picture. So let me make this minus 2y squared. So typo. Right, so 2. Okay, so the order on this one doesn't really make any difference. I mean, you can see order would not matter. It's just, or it does not matter. It's just as easy with the x as it is with the y, unlike the one up above. The one up above was actually considerably easier the way we did it than it would be the other way. But this particular one, the problem, it's a polynomial. It's really simple. Okay, so let's integrate this. So we're going to integrate this with respect to y. So 1 to 2, and then this inner piece. So 12y, take away x squared y, minus, and we add 1 to the power, so it becomes y cubed, and then it's 2/3 in front. And we're going to take that piece from y equals 0 to y equals 1 dx. Okay, so then the integral from 1 to 2 of, now 0 is going to make everything disappear because 0 would make this piece 0, this piece 0, this piece 0. So we don't have to worry about 0. So we're just going to put in y equals 1. So that's 12, take away 1 times x squared is x squared, minus 2/3, like that, dx. Well, again, that's pretty straightforward. This particular one is honestly so easy. We can do this by hand. This is the integral from 1 to 2. 12 take away 2/3. That's 36 take away 2. So that's 34/3 take away x squared dx. So that would be 34/3 x minus 1/3 x cubed. And then we would just take this from 1 to 2. And, you know, we can stick that into Maple, we can stick it into Desmos, whatever, and we would get a value. Actually, I think we can do this in our head. 68 take away 8, right? Well, I can do the two part in my head. So it'd be 68 take away 8, so it's 60 over 3 take away 33 over 3. So that's 27 over 3, which is 9. All right, so that particular one, if you're asked in a problem to do it fully by hand, that's what this means, right? This was fully by hand, right? If you're not asked to do it fully by hand, then usually what we mean is that you can kind of get to this last integral and then make Maple jump from here to here. So if you're doing the fully by hand work, that's right here. These steps right here are fully by hand. A lot of the times in these chapters it doesn't really matter, so you can make the last leap with Maple, but in case you're asked to do one completely by hand, that is how you do it. Let me show you the Maple real quick. All right, so there we have it, right? We integrated it from x equals 1 to x equals 1 to 2 and y equals 0 to 1, and sure enough we get 9. There's the answer right there. And you can see it's this surface. And I know it doesn't look like, these all look like squares, by the way. They're not squares. What's happening is that the scaling is not constrained in Maple, so it's making all the rectangles look like squares. But nevertheless, that's a rectangle down there because the x and the y scales are not the same. Actually, in this case, they are. This one is a square. But the one above is not. All right. Anyway, um, when you look at it, you're finding that volume underneath that surface, right, and above the xy plane. Now, it didn't give us any units, but let's say it did. Suppose that it said that they were in meters. So it would say up here, x, y, z in meters. So if it says that, then when you find this down here, this would be meters cubed, right? Because it's a volume. I'll add the box to include that.